Okay, hi guys. Good evening. Happy Wednesday. This is our December week 1. Okay. Hi Gabriel, haven't seen you in a while. Hi Kavi, you too. Guys, before I begin, there will be a replacement class this Sunday. Do you guys know that? Do you guys know that? There will be a replacement class this Sunday. Okay. And just a moment, guys. Okay. What is the replacement class for? This is actually for your December week 4. Okay. Let me explain, guys. Let me explain. Okay, can you see your December calendar? Okay, can you see the December calendar? From November 27th to this Sunday, uh, December 3rd is week 1. And then from 4th to 10th is week 2. 11th to 17th is week 3. All right, but there will be no week 4 because from 18th to 31st there will be a holiday. All right, our last 2 weeks. Can you see the calendar? It's on the screen right now. The December calendar from 18th Monday to 31st Sunday. It's a holiday. All right. So what about our week 4 class then? Okay, our week 4 class. Our week 4 class, we will replace it on this Sunday. Okay, that will be the December. That will be the 3rd of December. Can you see the calendar? 3rd of December is a Sunday. Okay, at the bottom right corner. All right, and as for the time, sorry, I haven't posted this yet. But our schedule would be here. Okay, would be here. Can you see on your screen right now? Mandarin one is 11 a.m. Okay, English would be 4:30. No, week 4. Week 4. Week 4. This is for week 4 class. Okay, guys, this is for week 4 class. So I know it sounds a bit weird, guys. I know it sounds a bit weird, but this Sunday we will be going to week 4. All right, and then week 3, week 2, week 3 is as usual. That means next week and the following week, right? So this Sunday, please come, This Sunday, please come. Okay, 4:30 to 5:30. Okay, 4:30 to 5:30. All right, I'll keep the lesson simple, it will just be a revision since you finish your trial and you are getting ready for SPM. So we will be doing revision stuff. Okay, as usual. I mean, what else can we do, right? Anyway, so I believe you receive your December notes, guys. I believe you receive your December notes. That would be this one. Okay. So okay, guys, take out your December notes. I believe there are 4 things inside. 4 stapled copy, whatever you call it, right? You find 4 things inside, right? You find 4 things inside. One is the short notes. Okay, the short notes, the one you can keep it aside. That is for your own reference. Okay, in case you need a quick reference, you need to see. You haven't get yet. Oh my god. Okay, if you haven't get it yet, then let me give you the soft copy of what we are doing today. Just today. All right, just today. Give me a moment. Let me download it real quick. Okay, the short notes you can ignore. I mean, if you really need it, then you use it, lor. But it's not really. You have the soft copy, so yeah, sure. Gabriel, you haven't get it, is it? You haven't get it, is it? Okay, I will put it in the chat. We are using this for today, lah. We're using this for today. In fact, we'll be using this for the following weeks. The coming weeks, we'll be using it. Okay, cool. All right, so I believe you guys have this. I mean, use it for now lah. Okay, use it for now. Okay, so today we are going to chapter 11. The motion chapter. The motion chapter. Okay, are you ready, guys? Are you ready, guys? We won't do anything too heavy today. We'll be doing. In fact, guys, I wish to say this. This chapter, don't focus too much. Okay, don't focus too much. As I say lah, you don't focus on any particular chapters lah. You study all. Okay, you equally study all. And if you were to ask me, one part that's the most important in this chapter would be inertia. You only focus on inertia. I mean, that's the most likely to come out. Graph, not so likely. The ticketed one also not so likely. Okay, so today we'll be doing, inertia stuff more. Okay, maybe I'll let you do some exercise too. Okay, come, let's go to question 1. Okay, as you can see, this is an experiment setup to study mass and inertia. 5 coins of 50 cents are placed in a can. Each mass is 10. The can is pushed, stopwatch is started, oscillation time is recorded. Okay, so guys, can you please change this to time? Okay, there's an error here. So what is this trying to say here? If the mass is 50 gram, the thing oscillates in 5 seconds. Okay, 5 seconds. And then if I use 250 gram, the thing will oscillate in 25 seconds. The thing will go whoop, whoop, whoop. But the 50 gram one just goes whoop, 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 whoop. So what does this tell us? What does this tell us? The higher the mass, the longer the time, or we can say the higher the inertia. Okay, the higher the mass, the higher the inertia. That means if something is heavier, then you would have higher inertia. Okay, guys, cool, huh? Cool, huh? I'm sure you already know this. So draw a graph of number. So you should see the thing just shoots up like that. All right, whatever, I don't care. Okay, constant variable. Constant variable. What is something that you don't change here, guys? What's something you don't change here? Anyone? What is something you don't change here? We are changing the mass. Mass of each coin, yeah, sure. Mass of each coin, I accept. What else can you say? You can say the bucket. Oh, you can even say the length of the string. The length of the string. This is a bit tricky because it's a bit hard to find here. Force you to push the bucket. Yeah, sure, no problem too. Okay, do yourself lah. All right, so as you can see, this is another inertia question. I'm just gonna skip. Okay. Are you guys using the notes I sent you just now? Because later we'll be doing some exercise. Okay. Right. Anyway, let's go to our motion. Let's go to our motion. Let's go to question 7. Okay. We have done this before actually last year, but this is a very good question to revise. Okay, let me ask you guys, do you remember what is the difference between distance and displacement? Do you remember what is it? Do you remember what is it? Okay, if you don't, let me repeat. Yes, distance is the total. Okay, distance is the total. Displacement is the straight line from beginning. Yes, the shortcut. Yes, you can call it that way. From the beginning to the end. That's the displacement. You guys remember, huh? All right. And when you divide it by time, distance divided by time, what do you get? The total is called, because distance is the total, So if you divide it by time, yes, you get speed. The large one, if you're taking in BM. What about displacement? If you divide it by time, what you get? What's the straight line speed? The shortcut speed. It's a very fancy word that we use. What is it called? What is it called? That would be our velocity. Okay, how large? Yes. Okay, so do not get it confused. Do not get it confused. Whenever they are saying distance or speed, you are dealing with the total. Whenever they are saying displacement or velocity, you are dealing with the straight line. Okay, I don't care. So let's see this question. The player runs from W to X, that means from here to here, X to Y, here to here, stops at Z, here to here, so stops here. So the guy begins here, start here, and the guy stopped here. All right, so guys, what would be the distance? What will be the distance? As we know, distance is the total, isn't it? All right, so the guy ran 28 from X to Y, and he ran 22 from Y to X. Sorry, W to X just now. Okay, now it's X to Y. And now another Y to Z, it's another 28. Okay, no, it's not 100. It's not 100. Kavi, he's not running back. So read the question. Okay, he's not running back. He stopped here. Okay, so it's 28, 22, 28. Okay, so that would be 78. Yes. Okay, 78. And then he took 20 seconds to do it, right? So what about the average speed? What about the average speed? Distance, we get speed. So 78 divided by 20, we will get 3.9 meter per second. Okay, you guys okay with this? This is the basic. This is the basic. What about the displacement? This one don't need to calculate because it's straight away from the starting point to the end point. So that will be 22. No calculation necessary here. It's just 22. And then since we have the displacement, how do we get the velocity? It's the same thing, 22 divided by 20. We get 1.1 meter per second. All right. So I know it sounds weird, sir? He's using the same time, but how is the speed and velocity different? That's the way it is. Because the velocity and the distance and the displacement is so different, man. So speed and velocity is so different, right? That's the way it is. So that's the way it is, right? And how do you get acceleration, guys? If I take this or this, I divide it by time again, I will get acceleration. I will get acceleration. Speaking of acceleration, do you guys remember this? Do you know how to do this? Just a question. Did this come out for your trial? Did they ask you to calculate this for your trial? Did it? No? Okay. Not surprising lah. This ticker tape thing, since it's a physics thing, so very seldomly they will ask. But we are gonna do it anyway. Right. First, just tell me, this is the motion of a car. What can you learn from this graph? You hate these questions. I know. My job is to make it easy for you today. Right, guys, what can you tell about this motion of the car? What can you tell from here? How is the car moving right now? Increasing speed, isn't it? Increasing speed, isn't it? The car is simply becoming faster. Okay, yes, it's accelerating. Good. Okay, so do you remember the formula of acceleration? Do you remember the formula of acceleration? Okay, it's velocity divided by time, yes, but what is the the formula, the real formula, the proper formula. Final minus initial. Kavi, you are half correct. Final minus initial over time. Not over 2, over time. Right? Over 2 is mean. No, it's math. Okay, so divide by time, because velocity divided by time. Correct? Correct? Okay, and then this is the final, this is the initial. Okay, tell me one more thing, guys. Tell me one more thing. Which is U, which is V then? We have 5 strips here. Which is the U and which is the V? You see, V is the final, right? U is the initial, right? Which one is the initial? Which one is the starting speed? Which strip? Which strip is the starting speed? Huh? What do you mean 20 minus 10? What do you mean? Which one is the starting speed? Guys, what is the start? Which one is the starting speed? This strip is the starting speed. The first strip is the starting speed. The final strip is the final speed. Common sense? Guys? Is it common sense? This is the speed of the car at the beginning. This is the speed of the car at the end. Am I making sense, guys? Am I making sense? Am I making sense? Right? Guys, don't be stressed about this because I'm not saying it's not coming out, but treat it like it's not coming out. Treat it like it's just one part of the equation, one small part in your whole Form 4, Form 5 journey. If you look at things that way, you will be less stressful, and funny enough, it's actually more productive that way. I know it sounds counterintuitive, right? The less you care about it, the more you learn it. You get what I'm trying to say, guys? You get what I'm trying to say? The less you stress about it, the actually more you know how to do. Okay, I know it sounds stupid, but that's the way it is. Right. So usually, okay, this is not clear here. Let me add like 2 dots here because that, sorry. Oh damn it, my pen has no more battery. Okay, give me a moment here. Okay. So I add 2 more dots here. Guys, can you tell me each strip here has how many dots? Guys, give me a moment. Okay, so how many dots here? How many dots here? Okay, guys, a ticker tape will always be 5 or 10. That's the beauty about it. All right. So what do? We don't count the first dot. So it would be, remember I said you don't count the first dot? Remember I said this? Whenever we count time, we don't count the beginning. Okay, if your tuition class is from 3 to 6, you don't go 3, 4, 5, 6. Oh, it's 4 hours. No, you don't. You don't calculate the starting point. Okay, it's 4, 5, 6 is 3 hours. Am I making sense? Am I making sense? Whenever we are calculating time, we do not calculate the starting point. All right, so we ignore the first point. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's always 5 or 10, right? Do you think, okay, guys, have you done this experiment last year? Have you done this experiment last year? Would you be so stupid to cut 6 or 7? Would you want to do something like that? Or would you want to just keep everything 5 to 10? Am I making sense? Am I making sense? If I keep things at 5 dots or 10 dots, it will make my life so much simpler. Isn't it? Okay. What do I mean? Guys, tell me something. 1 dot is how many seconds? 1 dot is how many seconds? Usually they will tell you this sticker tape is put at 50 hertz. The setting of this ticker tape is at 50 hertz. What does it mean? What does it mean? That means every second, this machine will make 50 dots. Every second, listen, every second, the machine will put 50 dots. So one dot is how long? Kavi, your figure is correct. you got one figure correct. Guys, this is the default setting. Every dot is 0.02 seconds. Yes, for sure. I am sure I mentioned this last year. Maybe you forgot. All right. It is for sure 0.02. Just like the dots here. It is for sure 5 or 10. Guaranteed. You find me a question with 6 dots or 7 dots or anything other than 5 or 10, you tell me. I have not seen it before. Not even in physics. Right? Okay, you see, if I have 5 dots, if the strip is 5 dots, that would be 0.1 second every strip. Correct? Because 5 times 0.02. If this is 10 dots, it would be 0.2 seconds. Can you see things are much simpler that way? Would you want to do 6 and make it 0.12? Your OCD is going to kill you. Right? Or would you be so free and say, you know what, I'm going to put 7. And then this thing is going to be like 0.14s. Your OCD will just go crazy, isn't it? Why not just keep it 0.1 or 0.2? Can you see the purpose now? Okay, many students have problem remembering 5 and 10 dots. Okay, it's not hard to see why they put 5 and 10 because it keeps the figure. You see, 0.1 and 0.2 is so nice. Your OCD says thank you, isn't it? Right? So 10 dots here, that means every strip takes 0.2 seconds. Hey, even you don't know how to calculate this, you see it's down here already. 0.2 first strip. Okay, second strip 0.4. Okay, means another 0.2 lah. Okay, another 0.2, 0.6, another 0.2, 0.8, another 0.21. Right? Right, guys? Easy, huh? Easy, huh? Okay, so now, okay, guys, I have a question here. How do you calculate U? How do you calculate the speed of the first strip? Listen, let me repeat my question again. How do you calculate the speed of the first strip? What's the formula of speed? Okay, distance divided by time. So what is the distance of the first strip? What is the distance of the first strip? Yes, it's 10. What is the time of the first strip? 0.2. Yes, you see? Easy. So 10 divided by 0.2 is 50 cm per second. Is this so hard? Right? I don't know lah, guys. I don't know lah. Somehow, right, this question, right, there will be this type of question, right, there will be a click moment. Okay? I don't know how to I can't quite explain it, but there will be a click moment when it happens. You will be like, oh my god, this is so easy. Why didn't I get this earlier? You get what I mean? There will be a click moment in your head. Okay? Usually it's because you lack a sense of urgency last time. Right? Last time you're learning this, like, oh my god, sir, this is not, I don't care about my Form 4 exam. Now when you start to care, when you start to get panic, you have the motivation to learn, this thing suddenly becomes easy. It happens, right? I know, right? That's why I hate teaching Form 4, because everyone in Form 4 have this honeymoon year mentality, right? Because they all say what? Sweet 16 what? Honeymoon year what? Right? Form 4 is the year you don't have any major exams, so you just santai lah. You just chill. Okay? And then I'm like, you know the peribahasa mencurah air ke daun keladi? It's exactly it. Okay? Whatever I pour to you, you will just reject it away. The water will just beat away. Okay? And then Form 5, you say, oh sir, did you teach this last year? I couldn't remember. Oh my god, you see? It's technically Okay, good. Yeah, that's good then. Right. So anyway, what about V? How do you calculate V? Oh, but you learn, but you forgot, isn't it? It's okay. It's okay. I don't mind repeating. Okay. What about V? How do you calculate V? What is the speed divided by this? Sorry, the distance divided by time here. What is the distance divided by time here? So it's gonna be 20 divided by 0.2. So you get 100 cm per second. That's not hard, guys. It's not hard. At least you can get this two part correct. You should. You should. Just by looking at it, 5 dots, okay, then you know. Oh, 10 dots, then you know. Right? So at least you can get these two correct. At least you get U and V correct. That's a 1 mark for you. Okay, easy 1 mark, isn't it? Okay, what about the other mark? What about the other mark? Okay, guys, how do you get acceleration? How do you calculate acceleration? Since now we have the V, we have the U, isn't it? The time, the problem here is the time. Okay, so what about the time? The time would be the total time. But listen, this is where things gets tricky. Many people will say, oh sir, that's very easy. 5 strips here. Each strip is 0.2. So the total time is 1 law. Right? 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 Wrong. Because when we are calculating one strip, we don't calculate the first dot. When we are calculating 5 strips, we don't count the first strip. You remember? So it's not actually 5 strips, it's 4 strips here. That's the formula. 1 strip, don't count first dot. 5 strips, don't count first strip. I mean, this is still the U, but when it comes to time, we minus off 1 strip. So it's actually 4 strips. So the time is actually 0.8, not 1. This is what many students will get wrong. I repeated this thing like 3 times last year. I'm sure I did, right? It's okay, right? So now you see you have your V, you have your U, you have your T. Just plug everything in. So 100 minus 50 divided by 0.8, that would be your answer. 50 divided by 0.8. So answer would be 62.5 cm per second square. Remember, it's a -2, because this is acceleration. It's a -2. Do you understand, guys? Are you able to understand? I hope it's a yes. Okay, cool, cool. That's all, right, guys? That's all. I don't know why people say this is very, very, very tedious. It's not tedious at all. It's just 3 steps, right? If you do this long enough, you just okay. Let me do it the quick way. Let me do it the quick way. Okay, you see, again, 10 dots here. Again, 10 dots here. I'm not gonna write anything. I'm straight away giving you the answer. See if you can follow, guys. See if you can follow. This one, 6/0.2, 30. Oh, this is the U, sorry. This V, 10 divided by 0.2, 50. Time, 1, 2, 3, 4, 5. 4 strips, because I -1. Times 0.2, 0.8. Acceleration, 50 minus 30 over 0.8. There, done. I mean, of course, you find a final answer, but done. See, guys, less than 30 seconds, the question is done. I don't get what's so difficult here. Guys, are you okay? Are you okay? Okay, you might say, sir, what about 5 dots then? What if this is like 5 dots? Same thing lah, okay? 6 divided by 0.1, 60. 5 dots, 0.1, 10 divided by 0.1, 100. 4 strips, 0.1, 0.4. Because 5 minus 1, 4 strips. So acceleration, 100 minus 60 over 0.4. Voila! Less than 30 seconds. Less than 30 seconds. Okay? So, Gabriel, did I somehow make this easier already? Many people say this is difficult. This is not, guys, it's not. I wish I can, empathize you and say, oh yeah, this is really hard. It's not. You don't even need to explain. Guys, heck, even chapter 5 explanation, that would be more difficult. Even operational definition is more difficult than this. Guys, operational definition, you need to write a whole sentence. What is the operational definition of acid? Acid is a substance that coagulates latex. You see, you need to write so many, but this one is just numbers. Right? There you go. Anyway, even if this is coming out or not, it's still very unsure. Okay, guys, if this is ever coming out, most likely it's gonna be in objective. It's gonna be in objective. It's gonna be in your ABC. You like operation definition more? Okay. Okay. Cool. Okay. Anyway, guys, if you say you hate this one I totally understand. I totally understand, right? This graph thing. Oh my God, this is the worst, isn't it? This is the worst, isn't it? All right, you should have. Yeah, I know. Right, guys. I have a trick here. Whenever you see a question like this, write down the flow chart. Displacement divided by time is velocity. Velocity divided by time is acceleration. Write this down first. Okay, write this down first. And write one more thing for me. Going down is gradient. Okay, going down is gradient. Okay, what does this flow chart even mean? Right, we look at this graph. What graph is this? This is a displacement graph, right? This is a displacement graph. So displacement graph, the gradient is going down, right? The gradient for a displacement graph is the velocity. Again, the gradient of a displacement graph is velocity. That means the gradient of this thing is the velocity. Easy to understand, isn't it? Easy to understand, isn't it? Okay, I'm gonna ignore this part. I'm just gonna explain this part. Okay, so if you look at this graph, can you see this part is positive gradient, zero gradient, negative gradient. Can you see? Positive gradient means the graph shoots up. Zero gradient means the graph stays. Negative gradient means the graph goes down. Can you understand this tree? This is basic math. This is basic math. All right. Okay, you see, this is how the magic works. Tell this to yourself, guys. Tell this to yourself. Positive gradient, positive velocity. Then you understand. Positive gradient, positive velocity. What does it mean by positive velocity? That means the car is moving forward. Positive gradient, positive velocity. The car is moving forward steadily. Steady speed, you see? Steady speed moving forward. Easy? Zero gradient, zero velocity. What does it mean by zero velocity? It means the car stays. The car is not moving. The car just stationary. Okay? And then the last part, negative gradient. Okay, negative gradient, negative velocity. Okay, negative velocity. What does it mean by negative velocity? It means the car moves backwards, back to the starting point. Right? So this car very weirdly he goes forward, he stays, and he goes backward, back to where he started. Voila, very simple. And how do you calculate gradient? That is your math ready. y2 minus y1 over x2 minus x1. Right? So the one is up to you already. Okay, you might say, then sir, what about the other part? What about if the graph looks the same, but this time is a velocity graph, all right? This is the same thing, right? Just refer it back to your flow chart here. Okay, if this is a velocity graph, the gradient is the acceleration. Again, the gradient of a velocity graph is the acceleration. Okay, so this graph here means the acceleration. Okay, same thing applies. Positive gradient, zero gradient, negative gradient. Okay, and then tell this to yourself, recite this to yourself. Positive gradient, positive acceleration. Positive gradient, positive acceleration. What does it mean? What is positive acceleration? Means the car is accelerating forward. The car goes, whoa. The car steps on the gas and the car goes, whoa, goes faster. Okay, so can you see it's different? Just now, the car steadily moves forward. Now the car steadily increases the speed. The car goes faster. Whereas this one, the car just keeps moving forward at a steady pace. All right, and then zero gradient, zero acceleration. What does it mean by zero acceleration? Guys, just because it's zero acceleration, the car is still moving. Doesn't mean the car stops. If I drive 100 on a highway and I keep driving 100, am I accelerating? I'm not accelerating. But I'm still moving forward though. See the point? See the point? If I drive all the way 100 from KL to Penang, okay, I am still moving forward, but I'm not increasing my speed. So this part here is actually just like this part. I move forward steadily. I move forward steadily. Okay, whereas this one, I move forward faster. And then the last part, negative gradient, negative gradient, negative acceleration. All right, negative gradient, negative acceleration. What does it mean by negative acceleration? Means the car is decelerating. The car slows down. Yeah, I won't. Yeah, I'm gonna fall asleep. Right. So what is negative acceleration? Means the car slows down. But the car slows down, the car is still moving forward, isn't it? Even if your dad steps on the brake, the car still moves forward, right? I step on the brake, the car still moves forward. Whereas just now, negative gradient, negative velocity means the car goes backward. So you see, forward, forward, forward. Forward faster, forward steady, forward slower. Right? So this is how it works. This is how it works. Okay? So I hope this is not too confusing. I hope this is not too confusing. Of course, going up is area lah. This one I usually ignore because it's not very common. That means in a velocity graph, the area is the displacement. Okay, if you want to learn this, it's okay, go and learn, but I really don't care. Okay, again, guys, this has very high chance of coming out in objective. So yeah, don't focus this too much. Okay, don't stress on, guys, don't stress on this. Do not stress on this. It's just like how I tell my students, do not stress on electrolysis. You see, none came out. In paper 2 anyway. You see, this time of the trial, I have so many students telling me, oh, sir, I'm going to die in electrolysis. Electrolysis is so hard. You see, none came out. See what I mean? See what I mean? Don't worry. Just tell yourself, psycho yourself, gaslight yourself that everything is easy. That student is me. Yeah, you're one of it, right? Right. So gaslight yourself that this is easy. If it comes up, bring it on. I'm ready. Okay. Sometimes we have to, guys. I believe the saying, "Fake it till you make it." Right? Fake it till you make it. Okay. Even if you are not there, you pretend that you are there. Okay, and you will be there. Right? It's called law of attraction, guys. It's called the law of attraction. Have you heard of the law of attraction? Okay, the law of attraction says you attract whatever you believe in. Okay, you attract what you believe in. If you believe that this is so damn easy, you're gonna ace all this shit, then ace this shit you will. Fake it till you make it. Right? Even you are not so sure, you are not quite sure about this. No, don't have that doubt. Eliminate that doubt. Tell yourself you're the best. You know how to do this. Okay, and it will come. Law of attraction. Okay, applies to everything. Great advice for life, right? Hmm. Wow, this turns into a motivation speak all of a sudden, right? Yes, make it to make it exactly, right? So law of attraction, law of attraction. Okay, you get whatever you believe in. Okay, and there you go. Right. Anyway, we look at this graph. Okay, so the displacement of the object, the total displacement. Okay, total displacement means you see, the car moves forward 30, the car stays, the car moves backward 30, back to the starting point. Then the car moves backward some more. What is also okay? The car moves backward some more 25, and then moves forward 25 again. So he ends up at the same point again. So what's the displacement? Oh, preacher, I see. What's the displacement? I go forward, I go back to the starting point. I go backward, I come forward to the starting point. So what's my displacement? What's my displacement? No. What's my displacement? What's my starting point and my ending point? What's my starting point and my ending point? I start at 0. I go forward 30. I stay. I go backward 30. I go backward some more 25, and I go forward 25. What's my displacement? Guys, let me visualize it for you. Let me visualize it for you. I am here. Okay. I go forward 30. I stay here. I go backward 30. Then I go backward 25 some more. I go forward 25 some more. And I end up here. So what's my displacement? What's my displacement? I end at the same point where I start. So what's the straight line? What's the shortcut distance? You get what I'm trying to say here? Guys, what is the displacement? What is the displacement? The displacement is 0. I start here, I end here. Right? Right? Okay. Kavi, what you're imagining just now is the distance. You see, distance is the total I travel. I go forward 30. I go backward 30. I go backward some more 25. I go forward 25. Okay. Distance means the total I travel. Am I making sense? So yes, this is 110. But this one, the displacement, I go forward, I stay, I go backward some more, I go forward. So I end up at the same point. So isn't it 0? Isn't it 0? You get what I'm trying to say here, guys? You get what I'm trying to say here? So the same thing applies here. Okay, so the same thing applies here. So calculate the velocity. Again, like I said, for this graph, velocity is the gradient. Okay, back to our reference here, the gradient. I see gradient here. So for displacement graph, gradient is the velocity. Okay, so the gradient from 0 to 5, 0 to 5, that means from here to here. So what's the gradient here? What's the gradient here? Very simple. So your coordinate 0, 0, 5, 30. Okay, So 30 minus 0 over 5 minus 0. This is y2 minus y1 over x2 minus x1, right? Right? So it will be 30 over 5, that will be 6 meter per second. So the gradient here is 6. Isn't it? Isn't it? What about from 5 to 12? From 5 to 12, guys, what's the gradient here? My graph is like flat line. What's the gradient? What's the gradient? My graph just stays not moving anywhere. What's my gradient? What's the gradient of a flat line? 0, yes, there's no calculation necessary. End of story. End of story. Guys, can you follow? Can you follow? Are you still on the bus or are you left behind? Please tell me it's the former. You can follow? Okay, good. Okay, good. Okay. Right, that's good. That's good. You're in the wheels of what? Don't be. It's okay. It's okay. Okay, sometimes, guys, sometimes, if you cannot understand something, it could be due to the fact that you are tired, right? My I suggest you this. Okay, this is a great tip to study. If you just keep studying the same thing and it doesn't go into your head, I suggest you take a break, relax a little bit, chill a little bit, and few moments later when you go back again, the thing just solved by itself and it's like so easy. Same goes to playing a game, playing your PC game, right? Your video game. If you come across a boss that you cannot defeat, okay, speaking from experience, guys, if you keep fighting a boss and the thing keeps killing you and it pisses you to no end, right? Sometimes when you take a rest, okay, and then you chill your mind, and then when you do it again, you will do it in one go. All right, because sometimes after you learn something difficult, your brain cannot process it. You need to give it time to process this thing. It's like digesting food, lah, right? Sometimes things cannot be forced. You have to learn it, chill a little bit, go back, and the thing will be in you. Right? Right? Should this fail, do it again. Okay? You get what I mean? Usually it will solve by itself. Okay? I don't know how to, I can't quite tell how does it work, but you come across something difficult, you rest a little bit, and lo and behold, the next time the thing will just solve by itself. I I I I don't know how to explain it, right? But that's the way it is. Okay, so I hope I'm making sense here. I hope I'm making sense here. Okay, guys, worst case scenario, you're telling me, sir, this one I really cannot handle. Okay, because got two graphs here. Because got two graphs here, right? You cannot handle both, right? Then I tell you what, you just focus on the displacement graph. Just focus on the displacement graph. Gradient is velocity, that's all. Focusing on one. Focusing on one. The velocity graph, you just let it go. Okay. Worst case scenario, lah. Of course, I don't want you to let go of anything, but if you really can't deal with it, then better one than nothing. So hope this helps. Right? Hope this helps. And okay, we'll do one velocity one, shall we? We'll do a velocity one. All right. Okay. Then we do the same one. We do the same shape one. Okay. We go to question 16. All right. So as you can see, this is the velocity graph, and as we have mentioned just now, the gradient of a velocity graph is acceleration. Okay, acceleration. So positive gradient, zero gradient, negative gradient. So positive acceleration, zero acceleration, negative acceleration. Okay, so determine the velocity when time is 3 seconds. Guys, they want to find the velocity in the velocity graph. This one, no calculation needed. Just look at the graph, right? At time 3 second, sorry, 3 is here. At time 3 second, what is the velocity? 12 lor. Okay, you see, this one no calculation needed. Okay, time 7 second. So 7 second, what is the velocity? That would be 6. Should be this easy. Hey, you never know, something like this might come up. Okay, I mean, you hope for the best, but you prepare for the worst lah. Okay, anyway, find the displacement in the time interval between 0 to 5. Okay, that means from 0 to 5, they want the displacement. Okay, so how do you how do you calculate displacement? Displacement, as I said, is you go up 1. Okay, you go up for the for the displacement. That means you go for the area. That means they want the area of this place here. Guys, may I ask, what shape is this called? Yes, it's a trapezium. So what's the formula of a trapezium? I mean, that's the dumb way of doing it lah. You can separate this into 2, calculate this triangle here, then you calculate the square here. That would be too much time. Okay, I'm just lazy like that. So might as well we go for the trapezium. So 1/2 times. Yes, a plus b. You see, you remember. So a here is 5, b here is 2. So 5 plus 2 is 7, and then the height is 12. Yes, math. Right, so 6 times 7 is 42. Okay. So 42. Okay, so acceleration. What is acceleration again? Acceleration is a gradient. From 5th to 9th. Okay, from 5th to 9th, see negative gradient here. So the coordinate here would be 5, 12, 9, 0. X1, Y1, X2, Y2. I'm just going to do it here because I don't want to go up and down. So Y2 minus Y1 over X2 minus X1. So negative 12 over 4. That would be negative 3 meter per second square. Right? How do we know the answer is correct? Because there's a negative here. You obviously, this is a negative gradient. So the car is slowing down. And do take note, this is negative 2, because this is acceleration. So it's a 2. Guys, are you okay? Are you okay so far? Are you okay so far? That's good. That's good. Gabriel, are you following? I hope it's a yes. I hope it's a yes. Again, this is just a small part in a one big chapter. I would say inertia is more important than this. Thankfully. Right? Thank God the easy one is the hard important one. Okay, so count your lucky stars. Okay, count your lucky stars. Right? Because if this is difficult and it's the important one, then oh, Lord have mercy. But turns out that's not the way, isn't it? Okay, guys. You know what? I'm just gonna end it here. If you want, you can go practice on the graph. I really don't suggest you doing it. Okay, but if you really want to practice, go ahead. Okay, and if you have some time, you want to do the inertia one, there you see another inertia question. Go practice the inertia one instead. That will be more important. Okay, guys, remember, this Sunday is a replacement class. I will see you at 4:30. Hopefully. Okay, I'll see you at 4:30. Right, so guys, do WhatsApp me if you have any question. I will see you this Sunday. Okay, have a good one, guys. I will see you soon. All right. Okay, that's all for today. I'll see you on Sunday. Okay, take care. See you. And yeah, what's up, Kavi? You want to ask something? Oh, you're welcome. You're welcome. Why the sudden appreciation? You're welcome. You're welcome. Okay, so yeah, you're welcome. You're welcome. That's what I do. That's what I do. I do this every year to all my Form 5s. Oh, that's sudden appreciation. I appreciate it. I appreciate it. Okay, I'll see you on Sunday. You're welcome. You're welcome. Okay, I'll see you on Sunday. Okay, have a good one. Okay, see you. Bye bye.